Lithium cobalt oxide, Li2, is a chemical compound that plays a crucial role in modern battery technology. It is an inorganic compound composed of lithium, cobalt, and oxygen atoms, and is a commonly used cathode material in lithium-ion batteries, Li-ion batteries. The structure of Li2 is typically described as a layered rock salt, where lithium ions occupy layers between cobalt oxide planes. This layered configuration facilitates the easy insertion and extraction of lithium ions, which is the key principle behind its use in batteries. Lithium cobalt oxide was first introduced in the 1980s and has since become a cornerstone of rechargeable battery technologies. Its primary application is in lithium-ion batteries, where it serves as a cathode material. The material is chosen for its high specific energy per unit weight, which makes it suitable for portable electronic devices like smartphones, laptops, and digital cameras. The specific energy density of Li2-based batteries typically ranges between 140 to 200 Wh/kg, making it competitive for applications requiring lightweight and compact power sources. This has made lithium cobalt oxide one of the most common materials for consumer electronics over the past few decades. In the field of electric vehicles, EVs, lithium cobalt oxide was initially used in battery cells for early electric vehicles because of its high energy density. However, Li2 batteries face several challenges, particularly related to their cycle life, safety, and thermal stability. Cobalt is a relatively expensive and resource-limited material, and the batteries can be prone to overheating and thermal runaway under high loads or extreme conditions. For these reasons, alternative cathode chemistries such as lithium nickel manganese cobalt oxide, NMC, and lithium iron phosphate, LFP, have been increasingly adopted in the EV industry. Despite these challenges, lithium cobalt oxide remains popular in devices that prioritize high energy density over cycle life or safety concerns. In recent years, research has focused on improving the safety and stability of Li2-based batteries by optimizing particle size, doping the material with other elements, or modifying its surface to prevent unwanted side reactions during charging and discharging cycles. Apart from its widespread use in consumer electronics, lithium cobalt oxide also finds applications in other specialized fields. For example, it is used in some medical devices, such as defibrillators and hearing aids, due to its high energy storage capacity. Li2 is also investigated in scientific research for use in next-generation energy storage technologies and materials science. For instance, researchers are exploring its potential in applications like solid-state batteries, where it could help overcome the limitations of liquid electrolytes. From a scientific perspective, Li2 has been extensively studied for its electrochemical properties and crystal structure. The intercalation and deintercalation processes of lithium ions within the material are central to the performance of lithium-ion batteries. Studies on Li2 also focus on its degradation mechanisms, including the dissolution of cobalt into the electrolyte and the structural changes that occur after repeated charge/discharge cycles, which ultimately reduce the battery's lifespan. The environmental and ethical concerns associated with cobalt mining have also prompted interest in finding alternatives to Li2. Cobalt mining is often associated with significant environmental degradation, and much of the world's cobalt supply comes from countries with labor and human rights concerns. This has led to efforts to develop cobalt-free cathode materials, although these materials have yet to completely replace Li2 in many commercial applications. In summary, lithium cobalt oxide is a vital material in the battery industry, especially for portable electronic devices due to its high energy density. While it has certain drawbacks such as limited cycle life, safety concerns, and ethical issues related to cobalt sourcing, it remains a widely used material for high-performance lithium-ion batteries. Future developments in battery technology may eventually shift away from Li2, but it will likely continue to play an important role in energy storage for some time.